So to begin with, I'm going to go and import this image. I'm going to go into import, and we're going to go grab this guy here and throw it into the engine. So there is my texture. If I go and look at it here, as I mentioned, this is a flipbook style texture that has 64 frames of animation in it. This is a 2048 by 2048 texture. And while that is a fairly high-res image, once you break it down into 8 frames, half of this is 1024 and half of that is 512. And so each individual image, which is half of that, is only 256 pixels. So this is not very high-res once you look at the entirety of the image. However, because this animation exists as sequential frames, I'm hoping that the motion of this image, once we actually see it moving and in play, it'll kind of detract from the fact that it's low res, and we might actually see something that looks pretty decent here at the end. Now, as with all textures when being used in Unreal, we need to create a material for this to be used. We can't just apply the texture itself to something. So I'm going to right click I've got a VFX folder here that I've created, which is where I'm going to be doing all of the visual stuff. So I'm going to go and right click here and create a new material. I'm going to call this VFX, which is the prefix that I use whenever I'm doing anything effects wise. And I'm going to do an underscore, and we'll call this explosion. And this is going to be the material that we use on this particle system to explode. So I'm going to go into this particular material, and I'm going to do a couple of things here before we do anything material-wise. So first, because this is going to be for a particle system, the sphere display here is not going to be of any use to me. So I'm going to switch it to a plane, so at least I'll be able to see what the image looks like a little bit clearer. The plane is right in the middle of the world, and this grid gets in the way, so I'm going to go and turn the grid off. So I'm just going to go to show and turn the grid off so we can see just our image. When you have nothing selected inside of your material editor, or you select the output nodes, the properties or the details pane is going to give you a list of properties for the material itself. Now, if you have something in your scene and you select that, the details pane shows you the details for that node. But when you have nothing selected, what we see in the details pane is now a list of properties for the material. There are 3 things that I would like to change on this material in order to get to a point where it's behaving the way that I want it to behave. First, I'm going to go change the blending mode. So right now it's opaque. And we actually want to have transparency. We don't want to have a square with a fireball picture on it. We want to just have the fireball. So I'm going to use the blend mode and change this to translucent. Now, when I do that, you're going to see that a whole slew of our outputs have gone and become grayed out. And this is because they do not work with the translucent blending mode. There are some of these things that you may want to use if you were creating glass or something like that. Having your roughness node would be pretty useful. You can actually go into the translucency section and change how that's being rendered, but we don't need to do that. The other thing that I'm going to do is that this is going to be an effect that is fairly large, and I don't want to run into the problem of these planes that are going to be generated by the particle system casting shadows or receiving shadows based off things in the world. So instead of having them lit by the world, I'm going to use the shading model of unlit. When I do that, a few other elements are going to disappear from the outputs. Now, we only have 4 remaining: emissive color, opacity, world position offset, and refraction. And in fact, we're going to ignore the bottom 2. We're only going to use emissive color and opacity. There's one other thing that I want to change in this node in order to help it along with our system, which, if I go and scroll down, we can see the usage of this material and the types of things that it's going to be allowed to be used with. I'm going to go and turn on the used with particle sprites. That is going to ensure that the system understands that this material works with particle sprites. And now we are able to start creating this material. This is not going to be an overly complex material, even though I'm going to go and drag my image into the material. Here is my texture sampler of this image. Now, even though this is technically a flip book animation, it contains 64 frames of sequential animation style effect, we actually don't want to use a flipbook texture. And so the issue here is that we want to actually be in control of when it plays which frames. Are you talking about the importing process? So the importing process, I just grab the image and I'm going to drag it into the material, like so. So let's say, for instance, instead of this being a fireball that starts at nothing and ends up extinguishing itself at the end, let's say instead this was an ability that a character had where their hand would extend and they'd get all kinds of little mystical orbs and things floating around their hands. So that's another particle system that we could do. And animation wise, that one, it doesn't matter when you play the animation. So a flipbook texture would work there. It'd be able to play the animation, and whenever the particle system appears on screen, wherever it happens to be in the animation was where it will start off. But since this is going to be a defined beginning and a defined end, we're not going to use a flipbook texture to do this. We'll actually let the particle system itself determine when to play these frames. That way there is a clear-cut beginning and a clear-cut end. The other node that's going to be really important to this, I'm going to right-click and type in particle color. Now, a particle color node is a special input node that will look at the particle system and any of the color modules that we create within it. So if we tell the particle color to be red, it's going to affect this node in the material, and we will get red output from that node. We need this to be able to change things like opacity and color of the material when we're creating the particle system. In order to make these two things work together, I'm going to take the color from the particle color, and I'm going to multiply it against the color of our particle system. This in turn is going to become our emissive color. And as soon as that's plugged in, we should actually see the material appear on the plane. The other thing that we want to do is we want to use the alpha, or the transparency that's nested in this image, and the alpha from our particle color. So if I take the alpha out, and just like before, I'm going to multiply it against the alpha in the particle color, this is going to give us the ability to now determine what the alpha looks like. So I'm going to plug this directly in, and I'm going to save this material. And I'm going to show you a little bit of a problem that we're going to encounter with this material. So you guys don't have to do this, but I will do this to show you the issue that we have. So I'm going to create a plane in my world that I'm going to go and rotate 90 degrees, and we'll go throw this material onto that plane. Now, the idea is that this is going to be faking something three-dimensional that has volume, not that it's actually just going to be rendered on a single plane, even though that's actually what's going to happen. When this thing gets rendered too close to geometry, something bad happens with the way that it's rendered. If I drag the image into the ground, you can see this. The illusion of this being a voluminous effect is broken, and we can actually see where this plane bisects the ground. That's kind of bad. We don't actually want to have that happening. So we're going to go and manipulate the opacity node here to kind of soften that effect a little bit. This is done with a single node called a depth fade. So if you go and create a depth fade, this is going to give us control over that transparency. This is a really simple node to use. Whatever you currently have plugged into your opacity goes into the opacity of the depth fade. The output of the depth fade becomes our new opacity. Now there's another variable here called fade distance. You can see in its detail panel that it has a default value of 100. And that's probably good enough for what we need. If I recompile this material and we look at what that's done to our scene, you can see that now instead of it becoming a hard edge where it intersects with the ground, it fades out. Now that 100 that is in here as a default value is the number of units from where the intersection happens until the object is at 100% opacity. So it takes about 100 units for it to go up and become completely opaque again. I'm going to go delete that plane because we're not going to use it. And that is literally all we need to do in order to create the material for this thing. It's a pretty simple material. I'm going to go and just save this out. And we can close this to go and start creating the actual particle system itself. In my same folder, I'm going to go right click, and under create basic asset, I'm going to create what is called a particle system. I'm going to go give this the name of VFX, or maybe we'll use PS for particle system, and then I'll do underscore explosion. I'm going to name this what it is. Now, if I were working on a game that had multiple kinds of explosions, a grenade explosion, a rocket explosion, a car explosion, or a gas can explosion, all of these things would be different visual effects. I would probably want to put the name in here that identifies what kind of explosion this is. Naming things explosion 1 through explosion 12 is pretty bad when you have to go and assign it and you can't remember, was it 6 or was it 8 that was the gas can? Can lead to problems. And so things like gas explosion would be a really good name for this, or barrel explosion. But since I only have a singular explosion effect that I'm doing in my project, the name explosion is probably good enough. I'm going to open up the particle system. And what's going to open here is a editor called Cascade. Now, it's worth pointing out that Cascade is actually Unreal's older particle system. They have a new one called Niagara, which hasn't completely overwritten this one yet. It is a newer and better looking particle system that operates very similarly to the way that the material editor or the scripting does in a blueprint. It is all node based where you plug things in together. This is using a little bit of an older system that was common in Unreal 2 and 2.5 and UDK, where you have these modules and these systems together. So it's a little bit of a different interface. This will suffice for the creation of our explosion, but eventually Cascade will be removed from the engine and it'll be completely overrun with Niagara. To give you a little bit of a tour, take a look at what we are looking at here. Over in the left, we have a viewport giving us a preview of our particle system. There is a emitter already. This large window on the right is a collection of all the emitters that make up our particle system. By default, we only get a single emitter in there, and it has gone and given us a few default parameters in this so that the emitter works. You can see that it's spawning these little crosshairs and they're drifting upwards. As I mentioned, these are emitters. This is the list of emitters that we can get here. Ours is going to be pretty simple. We're going to make 3 emitters to make this effect. But this can get pretty complex. I've had some that, have 17, 18 different emitter effects in here, depending on the complexity of what it is that you need to do. In the emitter, we have a list of the modules that exist to manipulate these emitters. Some of these nodes cannot be removed, and some of them are actually required. In fact, one of them is named required. And if you look on the modules, you'll see on the right 2 little boxes. These are little icons. These are check boxes that you can turn on and turn off. The first one, the little gray check mark, is the ability to turn on and off that particular module. Now, the actual emitter itself has a check mark as well, which we can turn off, and then the emitter is no longer turned on. We can also solo it with the little S here. This is going to remove all of the other emitters from functioning and give us just this one by itself. The other icon that you see in each of the modules is a little graph, and that's what we have down here in the bottom, the curve editor. Now, this is going to become really, really handy when we start editing some of our values. Sometimes typing in just the numbers, it can be really hard to visualize what it is that you're trying to do. And so being able to turn these into a graphed version of this using curves is going to give you the ability to kind of visualize things in a little bit of a clearer way. And we'll do this when we get into manipulating some of these values so that you can see them. Over in the bottom left is our details pane, which is where we are going to be interacting with our system the most. So we're going to be going and turning on and off various things in this system. So the very first thing I want to do is I want to select the particle emitter itself, the very top of this node, and we're going to go make some changes to the default base layer of this emitter. So first, I'm going to go and rename it. This is base explosion. Now again, we're only going to be creating 3 emitters here, and it will be fairly easy to tell which is which. But again, once you start getting into a large collection of emitters in the range of 20 or so, it can be really hard to remember which is which. And going and soloing out each one until you find the effect you want is kind of tedious. So by going and giving these things a name that is easy to remember what it's doing, will make it easier to identify what each of these things are. If you double click on one of your emitters, you can also minimize it down to a little color. This color is identified in the Cascade section, emitter editor color. And this is, again, once you start getting a large number of emitters, you can go minimize the ones that you're either you've completed, or that you no longer want to work on, giving you the ability to kind of concentrate on the ones you are still working on. The only other thing that we're going to do in here, I think this one's all going to be good just like this, is we're going to go down into the required section, and this is elements of the emitter that are required. So the very first thing you'll see here is that it requires a material. We've already gone and built our material, so using the drop down, I'm going to type in VFX, since all of, again, my materials that are going to be effects driven all start with that prefix. This gives me just the only material that we've created so far. I'll go and select that, and we're going to see an update. In this update, you're going to notice that we're not seeing the actual animation play in the way that we want it to play, right? It is just showing us, if I go and zoom in on this, each individual frame still exists on the card the way that the original texture was doing. And so not exactly the way that we want it to be presented just yet. Going down, we're going to go to sort mode. Now, sorting mode determines what order things are drawn in. So we have a whole bunch of particles here on the screen. In fact, if you look in the bottom right-hand corner of the display, it'll tell you how many particles are on your screen. We got 20 to 21 of 23 allowed particles on screen at once. And right now, the order that they're being drawn in, the sort mode is set to none. So it's just drawing everything all together. And we're going to go in here and we're going to use newest first. This is going to make the newer particles draw before the older particles. This is going to be important once we start making this effect a little bit larger and take up more space. The next thing that we need to do is tell the system, let's go back into required here. We're going to tell the system that we don't want this to be an ongoing particle effect. So when you look at what's going on right now, this is essentially, it's looping. It's constantly playing. And that's because in the duration section, we are currently using emitter loops set to 0. 0 means indefinite. I'm going to go switch this to 1, and we're going to get 1 loop of this animation. Once it's done, at the bottom of our window, we'll now see the word completed. Now, when it's completed, the editor will play it again so that we can see it again. This does not mean it's looping. The completed word here is telling us that the system has come to an end. And then the system is just going to preview it again for us. I'm also going to go and change the duration that the emitter is going to be allowed to emit. I'm going to go from 1 to 1.5, making it last just a little bit longer. This is the amount of time that the emitter will be allowed to spew out particles. With that done, we can scroll down a little bit further, and we're going to go into the section called Sub-UV. This is where we're going to take our first steps into making the animation play the way we want it to play. Sub-UV is the way of determining how your UVs are subdivided. In this case, currently they're not subdivided, and we want to go subdivide them the right way. If you look at the interpolation mode, this is the way that it's going to go from one frame to the next. And there are 5 options here, starting with none. The next option is linear. Linear is going to start in the top left and end in the bottom right, going from frame by frame by frame. Linear blend is going to do the same thing, starting in the top left, ending in the bottom right, but it's going to blend the frames together, meaning doing a kind of overlap. So with linear, only one frame is ever visible at a time. With linear blend, you're going to get a crossfade. So the first frame is visible, and as it starts fading out, the second frame starts fading in so that we always see more than one frame. This is good if you want to get something a little bit more fluid out of your animations. That's actually going to give us a little bit of an after effect with our image that we don't want, so we're not going to use that. Next is random. Random will play random frames from the animation. This is good if you wanted to do something like a muzzle flash on a weapon. Having several different muzzle flashes in a texture sheet and just having the particle system randomly choose one every time you fire will make the muzzle flash look a little bit more organic, natural. Then we have random blend, which will also play a random frame, but will crossfade it with the next frame if you're using animation. We're going to be using linear since this was rendered in a linear fashion. We are going to go to our sub images horizontal, and this is an 8x8, so I'm going to tell it there are 8 horizontal images and 8 vertical images. Once that's done, you're going to notice that we have a very different looking particle system now. It doesn't look good, not just yet, but it's starting to give us something a little bit more natural. The other thing that I'd like to do is go into the rendering section, and here there's something called UV flipping mode. Now this is going to allow us to get a little bit more variety out of this system. Instead of seeing that same animation play over and over and over every time there's an explosion, we want to make the explosion look different every time. And this is the first step that we're going to take in doing that. UV flipping mode is going to change the UVs on our plane when it gets rendered every time. Here we have flip UV, and that's going to flip U and flip V. So the image will be upside down and backwards. Flip U only will make it inverted, and flip V only will flip it upside down. Random flip UV is going to randomly flip every other frame, or randomly flip frames as it creates them. Randomly flip U only, randomly flip V only, will do it either horizontally or vertically. And then the one that we want, random flip independent. This is going to make every single image or every single plane that gets rendered, it's going to randomly give it a U of 1 or -1 and a V of 1 or -1, giving us 4 possible orientations for our little particle. Now already we're starting to get something a little bit more random in the way that it's being created. Now it looks like a little tiny blowtorch in blowing these things out, but this is the first step that we're going to do here in making this work correctly. The next module we're going to adjust is called spawn. And the idea with the spawn module is that it's going to control how the particles are being created or born. Here, this is broken into 2 sections, the spawn rate and the burst. Spawn rate controls how many particles per second are allowed to be born. And burst is how many particles in an instant are created. First, I'm going to set our spawn rate to 0. This is going to make it so that it doesn't spawn particles per second. When we do this, we lose our entire system, but that's okay. We're going to get it back. In here, we also have a distribution model that we can change. I'm not going to touch on this just yet. We're going to look at this when we get into a different module because it'll be a little bit easier to explain when we get there. So, rate constant is now 0, meaning it's no longer allowed to spit out particles. Under burst, there is a particle burst method, instant, which is what we want, and then we want a burst list. So a list of when it's going to burst particles. I'm going to hit the little plus to create a new element, which is labeled 0. If I open this up, we can tell it how many particles we want it to generate. Let's do something simple like 5. With that number changed, we should now see our particle system spitting out 5 particles randomly into the world. They are spawning, and drifting upwards. They're all spawning at exactly the same time. And that's it. That's really all we want to change in regards to the spawn rate. The next one we're going to change is going to be the lifetime. The lifetime is going to give us how long these things are allowed to be alive in seconds. Currently, we have 1 second as a minimum and 1 second as a maximum, meaning all of the particles are going to live 1 second. I'm going to increase the maximum to 2 seconds, and let's make the minimum 1.5. Now, with these numbers becoming different, you're going to notice the particles fade out at different rates. Some live longer than others. This too is going to help the system look a little bit different every time we see it. So that one was pretty easy. There's not a lot to do in the lifetime. The next one we're going to edit is called initial size. Whenever you see a module that starts with the word initial, this means when the particles are born. There's an initial size, but we can also edit the particles' size. Initial size means when they're born. How big are they? Here, we've got some variables that we can change. We've got X, Y, and Z. Now, the particles are always facing us in X, which is how we kind of view them here. And that's going to be useful. I'm going to go and change their scale a little bit in X. Right now, they are 25 units across. And 25 units is centimeters. So we're seeing something that is about a foot wide, not very big. And if you remember, the size of the barrel that we are exploding is 66 units in diameter and 99 units tall. So our little particle system right now is just that. It's too little. So I'm going to go and increase its size. Let's make it 2 meters or 200 units. I'm going to also set a minimum of maybe 1.5 meters or 150. When we do that, we should now see these things being spawned at a much larger size. Now, I don't have to change the Y and Z scale. They're fine the way they are. Again, these are cards or planes that are always facing the camera, and X will control that scale, so we don't have to go and manipulate the other numbers. So now that we have an initial size, let's go and make our animation work a little bit better. I know we've got a velocity and a color over life module here to play with as well, but let's go add another module to play with first. Again, our particle system isn't looking so good. We're just seeing the first frame of the animation. And because this effect, the particles that we're rendering actually grow over time, we're actually not seeing the entire size of this thing. This is a small image on a big card. And so in order to be able to see the whole thing, we have to be able to play the animation through. Let's add a new module to do this. I'm going to right click inside of the empty spot in our emitter. And here we're going to get a list of categories of modules that we can add. And the one that we want to add is going to be a sub UV. This is going to be sub image index. Now, what this module does is it gives us the ability to tell the system when to play which frames. This is going to be important to making the animation play the way that we want it to. To create this module, I'm just going to click on this button, and the new sub-image index will appear at the bottom of the list. Now, if you really want to, you can go and drag it into another position so that it has somewhere else to live. But the order doesn't really matter here. It's just about sorting them. I'm going to select the sub-image index. And if we go look at its properties here, we have a distribution float constant curve. This means that there's a curve that goes through time, the value at the bottom of this graph, and value, the number going up the side of this graph. There's only two numbers we really want to pay attention to right now, which is the in value and out value of each point on the curve. The in value is the time in the particle's life. 0 is when it's born. 1, down here, the in value, is when it dies. And we set our particles to be a variation between 1.5 seconds and 2 seconds in length. It doesn't matter if it's a 2-second particle or a 1-second particle. 1 is the last frame of its life. This is a normalized value pointing at how long the particle is alive. We are going to make this play the animations in the way that we want them to. We have an 8x8 texture sheet, which means it contains 64 frames of animation. The out value is the number of the animation frame we want to see. So at time 0, the in value, we are displaying frame 0 of the animation, the out value. In the next point on our curve, the in value, the last point of the particle's life, should be an out value of 64 frames later, meaning 63. Once this is done, we should actually see the animation playing on our particle system. Again, it doesn't matter if they live 2 seconds, or a second and a half, or 30 seconds. They will always play first frame when it's born and last frame when it dies. Our variation in time means that not all of the frames are going to be in sync. Now we're getting a little bit of an issue here with a Rorschach pattern or a mirroring in this, in that because we're mirroring our UVs in both directions randomly, we often see randomization of the particle system, meaning we often see it completely mirrored along one axis. That's fine. We're going to go and adjust this at some point. For now, it's okay. Let's go back to where we were in our list of modules and continue to edit them. The next one we want to edit is our initial velocity. Again, the initial velocity is the speed that the particles have when they're born. Again, the word initial being related to when the particles are created. This is where we're going to talk a little bit about the distribution and how that works. Inside of the distribution, we have different variables or different types of distribution that we can play with. Constant is going to give us a speed in X, Y, and Z that is constant. So for instance, if I put 250 in Z, the particles are going to be born moving upwards at 250 units a second. If I put minus 250, the particles will go down at a rate of 250 units per second. This is true with both X and Y as well. If I go into the next one, a vector constant curve, this is going to give us a curve, which again I can open up. By default, there are no points on it, so we're going to go and add some. And just like we did a moment ago, we have an in value being when the particle is created, at this point 0, and we have another in value down here, which I can set to be when the particle dies, and we can now set an out value, which is going to be its X, Y, and Z speed. So for instance, I can say when the particles are born, make their speed 500, so they shoot up. And when they die, we can set it to minus 800, so that they slow down towards the end of their death, and they're actually moving downwards when they die. Now we're not going to see too much change here because they're actually dying when they hit this speed. The next one we can go to is a particle parameter. A parameter, just like when you create a material, is a module or a section that can be edited at runtime. So let's say you had a particle system where let's say we have a wizard or witch who's throwing abilities forward, and there's this big glowing orb that manifests around their hands. And maybe the longer you use the ability, the more powerful it gets. Well, we could use a parameter to change the color of the particle during gameplay as certain things happen. Next, uniform. Uniform gives us a minimum and a maximum speed at which these things can travel, and it will randomly choose some area in between those variables. And then finally, a uniform curve, which again is going to give us a curve with points on it that again has a minimum and a maximum. For our initial velocity, we're going to be using vector uniform so that we can shove the particles out at different rates in different areas. I'm going to do this at a rate of, let's try 50 in X and 50 in Y. And let's do maybe 35 in Z. And let's also give it the ability to go negative 50, negative 50, and negative 35. So this means that the particles can go anywhere within a 100 unit variance here. They can go positive X 50 units and negative X 50 units. They can also go Y 50 units and negative 50 units. And then we've also got a smaller Z. Now the reason I'm doing a little bit of a smaller Z is to make it look like it's blowing outwards more than up and down. So cool. That works pretty good. The next node we've got is called color over life. And color over life is just that. What color the object is going to be at what point in its life. Here we've got a vector constant curve, which has got 2 points on it. I'm going to go and manipulate, you guys don't do this, but I'm going to go and manipulate my material to make this a little bit more evident. I'm just going to swap out its color node with its red node. This is going to make my effect look black and white. Instead of using full color, I'm just using the red channel to determine its color. Now, when the object is born at a time of 0, its color out value is currently set to be white. When it's dying, a value of 1, its out value is currently also white, meaning the particle is always going to be white. If I change the color when it's born to be maybe a bright yellow, it's being born at yellow and we can see it fade out to white. If I go and add another value here, let's go make this a little bit brighter orange. Maybe a little more red in there. So now we have it being born yellow and shifting to red. This is happening when it dies. It hits that orange. In fact, we can go and make that even warmer in color. I could also add a couple more nodes here. Now let's make it orange at halfway through its life. And when it dies at 1, we can turn it black. So now it's being born yellow, shifts to orange, and eventually red, and then shifts into black. Now these values, while they are normalized, can also be increased a lot further than this. So for instance, right now the color that we're seeing is 1, 1, 0, or yellow. I can also make this 10 times yellower than yellow by increasing these values, and now we're going to get an even brighter yellow. So you can actually make all kinds of different effects with this, making yellow and green and blue explosions that happen. Now, since what we're doing is actually just going to use the color from the image, I'm going to replace this on my image. And I don't actually want to manipulate our color by what's going on there. You can see that it still actually looks pretty decent, even with the color being applied. What I'm going to do is I'm going to remove point number 2. I don't actually want this to exist. And I just want 2 points. In fact, we can delete this and just add a single point and make this just white when it's created. This is going to make the effect just look the way that it looks inside of its nodes, inside of the texture. The area, however, that we do want to operate is going to be the alpha over life. Now, before I start editing this, let's actually take a look at what we're seeing here, because we're not actually seeing this exactly the way that we will in game. That's because it's on a really black background. Up at the top in the toolbar, there's something called background color. And I'm just going to click on that and brighten the background a little bit so that we can actually see the particles dissipate the way that they are in the image. So cool. That actually looks pretty decent. What we want to do is we want to go and add some transparency to the way that this is being born. Essentially, I don't want them to pop into existence, but I want them to seem like they actually generate. They actually are coming from a point and growing out. To do that, we're going to go change our distribution in our alpha over life. So what I'd like to have happen is I'd like to have them born completely invisible and very quickly have them become visible, stay visible for quite some time, and then I'm actually going to help them fade out at the end. So we're going to do a constant curve, and in our curve we want to have 4 points. Birth, which is going to be completely invisible. We want to have a second point for when it gets to its full visibility. A third point where it starts to become invisible again, and then a final point when it dies, completely invisible. So that'll be 4 points, okay? 3, 4. In the first point where it's born, we currently have a time of 0 and an out value of, well, 0. It's going to be born completely alphaed out. The next point, 1, I'll bring this up a little bit so you can see the values here a little bit better. The next point, let's do this at maybe 10% in. So 0.1. And we'll make its out value completely visible. And we're not seeing anything yet, and that's because the other 2 nodes are still manipulating it. So let's go to maybe 85% of its life and still make it completely visible. And in the third node, at 1, when it dies, let's make it invisible again. So what should be happening now is instead of a pop when the particles are born, we should actually see them over 1/10 of a second fade in. Now this controls how quickly it takes them to fade in. If I set this to 0.5, they'll slowly fade in before they completely disintegrate. I don't want that. I want it to be a very quick fade in, followed by a very nice fade out. So that's already starting to make it look a little bit better. Okay, so at 0 in its life, when it's born, it's completely invisible. At 0.1 of its life, it's completely visible. At 0.85 of its life, it's completely visible. And then when it dies, it's completely invisible. Now, let's go take a look at this in the curve so we can actually see what it's doing. I'm going to go and bring my curve value up here a little bit. And in order to see this in the curve, we need to go hit our little graph button. And I'm going to hit the fit button so we can see this on the graph. And here is color over life and alpha over life. Now I'm going to turn off color over life so we just see the alpha. That's the little yellow button at the end. Here we can see that it's 0 when it's born, goes to full opacity, stays at full opacity, and then becomes invisible again. This is giving us a really, really, really nice blend in this area. So you can see how useful this graph would be. In fact, it's going to become even more useful when we get into one of the next areas. Now we've already edited our subimage index, so we don't need to edit it again. Let's go manipulate this and make it look even more dynamic. Let's go create a size by life. I'm going to go right click and go to size and size by life. And what this is going to do is it's going to give us the ability to scale this thing up or down depending on how old it is. And this is going to help us with that initial burst of energy that we're supposed to be getting. Right now, the particles are kind of just living at the same scale all the time. And while it kind of looks explosion-y, we're not getting that oomph of force that we want. And so adding a size by life, I'll click on this. I'll go into that module. Is going to give us the ability to now do that. It's going to give us the ability to change that oomph. what I'd like to do here is I'd like to give it, again, 4 points. An initial birth, and then its full size. And then I'm going to slowly have it ramp up before it kind of dissipates at the end. By default, we have 2 points in here, so I'm just going to add 2 more. And let's go and play around with these values. So the first value is when it's born, 0. And I'm going to scale it to 0. This means it's going to be born, well, completely invisible. So when it ramps up in opacity, let's ramp up its scale too. So 0.2 is going to be at 10% of its life, 0.1. And let's go scale it up, I don't know, 3 times. So 3, 3, and 3. The next point, 2. Let's do this at, I don't know, half of its life, 0.5. And let's also scale it up to 3. 1 and 1. In X, Y, and Z. We're going to talk about these tangents here in a moment. And then finally, the last point, 1 in its life. You can see it's actually imploding on itself now. And that's because, again, it's going back down to 0 scale. So let's just go to 2, 2, and 2. So it starts really small, grows over time, and then kind of shrinks in on itself a little bit as it turns into smoke. I'm going to turn off the color over life nodes here because I don't want to visualize them anymore. And instead, I want to visualize the size by life. And we'll go and frame this so that you can see it. So here's the size by life that we are getting. We've got a X, Y, and Z value that is being manipulated here. And I probably want to make them the same. We're going to go 3, and 3, and 3, and 3. 3, there we go. So here's what our graph looks like. The particles are born small, 0. And at 10%, they scale up to 3 times their size. At which point they're going to kind of stay at that size before they slowly start scaling back down to 2 times their size. Now, while this looks pretty good, these tangents that were being manipulated here currently aren't doing anything. That's because what we're looking at is a linear progression from node to node. The interpolation between this node and this node is linear. What that means is that it just goes from point A to point B without taking any other kind of path. And we do want to soften this. We do want to get to a point where this is going to be a lot smoother. That'll prevent this from shuddering. So in the node here, I'm going to use the drop down and change from linear to curve auto. When I do this, you now see that instead of it taking off and going into that size, we now have a nice fluid curve going in that direction. I'll do the same thing for the next one. Curve auto. Curve auto. And curve auto. Now when I do this, 0, 0, 0, 3, 3, 3. So these guys I want to manipulate. There we go. So once I do that, we can see the curvature that we're getting here a little bit. And what I want to do is I really want to soften this up. I don't want any plateaus like this, but I kind of want this to be one really nice mode. And so what I can do is I can actually Control Alt and select a point, and I can go and move these things. So you can see I can move the X and the Y and the Z, and I'm going to try and adjust these things here so that they end up a little bit more fluid. The idea is to adjust this curvature so that we end up with something a little bit more balanced. And I can go and affect all of these guys here and give them the same kind of curvature. This is the X, Y, and Z scale. And you can see that I'm with editing this, I can actually get it to be a little bit smoother, which is going to give us a little bit of a better effect in this. And so this is one of the really strong suits that that Unreal has, is the ability to go and manipulate these points here. And actually see this on a graph, which makes it a little bit easier to actually visualize what it is that you're doing. So I think at this point we've kind of done enough with what this thing is doing in terms of its visual quality. The only thing I really want to work on is to get rid of some of that mirroring, as it were. Try and give this a little bit more of an organic shape. The way that I'm going to do that, I'm going to add 2 more nodes. These are going to be rotation nodes. So first, we are mirroring this on X and Y, or U and V, but we can actually go a little bit further with the rotation. I'm going to right click, go to rotation, and I'm going to add an initial rotation. Again, initial here is referencing when the object is born. So this is a rotation that this object has when it is born. When I add this is a pretty simple node. It's got a value between 0 and 1, meaning 0 rotations and 1 rotation. This is going to give us a much different effect in that every single time this thing bursts, the particles are going to be completely misaligned. They're going to be completely random in their orientation. This will allow the system to look very different every time we see it, while still kind of always looking like the same type of effect. That's not so bad. The other node that we're going to add is another rotation node, and what we're going to be adjusting now is once the particles are born, let's actually make them rotate. This is going to give us the effect of the particles drifting in the air a little bit. And again, we'll kind of add a little bit to that random effect. So if I right click and I go to rotation again, we want to add an initial, rotation rate. We want to add an initial rotation rate. This is the rate at which the objects are spinning when they're born. The default values you're going to see are not so good. They are rotating a random amount between 0 and 1. And kind of looks like our effect is being flushed down the toilet. Now, it looks that way because the speed at which it is rotating is somewhere between no rotation and 1 rotation. But we actually want it to rotate both directions, which means our minimum can't be none. Our minimum has to be a negative value, rotating in the opposite direction. Let's do 1/10 of what it is, so minus 0.1 and a maximum of 0.1. When this happens, the particles are still spinning, but they're only spinning at a rate of 1/10 of a full rotation every second. Now you can play with this to get the effect that you're looking for. Here's 0.25 and 0.25. Again, it starts to feel a little too quick to me, a little too turbulent. 0.1 and 0.1 seem to work quite nicely. We're getting a really nice kind of effect where it looks a little different every time. So just like that, I would say that this emitter is actually done. We're going to go and create a second emitter. Now, one of the things that I want to do is I don't just want to have an explosion in the world, but I want to add a little bit more of a connection between the world and the emitter. And we can do that in a couple of ways. So this is going to not only give us a really nice connection between the world and the emitter, but it's also going to add to the randomness of the emitter. So we've got one random effect going on. If we add a second random effect on top of that, we're going to end up with two random effects, which are going to increase just how different this looks every time we see it. Just like when we made this particle system, we started with a material. We're going to also need to start with a material for our second emitter. Now for this one, we're not going to use a texture. Well, we're going to use a material, but we're not going to use a texture. We'll create something mathematically. If I right click, I can make a new material. VFX _ embers. I'm going to make little glowing embers that burst out from this explosion. With the material editor open again, we're going to go and set the same settings we had before. Translucent, unlit, and use with sprites. I'm going to also turn off my grid and display this on a plane like so. Now this node is going to be insanely easy to recreate. First, we, like before, need a particle color, since that's what's going to drive the color of this object. And then we just need to make something that looks like an ember. And that's fairly easy to do. I'm going to create a radial gradient. We'll use the exponential radial gradient. I'm not even going to plug anything into this. We'll just use these like this. So let's create a couple of multiplies. I'm going to hold M and click. And we'll multiply our color versus this thing. And we'll multiply our alpha versus the exact same thing. We have our color and our transparency now. This is going to give us just a little dot, which is perfect. It's really all we need from this. Okay, so really, really simple material here that doesn't really need to do anything beyond this. So we're just taking our particle color and multiplying against this black and white gradient. And we're taking our particle alpha and also multiplying it against the gradient, which is going to give us just a little glowing dot. I will go in, close this material after saving it. And now something really cool is going to happen that you may have noticed this in the engine before. If we go back into our emitter and I still have my embers material selected, I'm going to right click in the empty spot and make a new sprite emitter. And when I do that, it's actually going to use our newly created material. When you have a material selected, or anything really, and you create something that needs a reference to an object of that type, Unreal will automatically go and shove it in where it's supposed to go. So in this case, in my required slot, you can see that it plugged our material in for us. Now this appears to break our particle system. The explosion looks like it's gone. It's not, actually. The problem is that our new emitter is looping, and the explosion is not. So the explosion happened once. If I restart the simulation, we see the explosion, and then the emitter just keeps spitting out particles. Now, this is not actually a flaw. You can design particle systems that work in this way. Maybe you want to have it so that when you shoot things, you know, maybe there's a big oil can in your world and your character pulls out a gun and shoots it, and you get an initial blast of the bullet hitting the object, you know, a little bit of a spark or something, and then you can have smoke drift out. And that's it. You would always have smoke drifting out. That kind of system would require a once-off emitter and then a looping emitter. Our system is not going to work in this way. Our system is going to be a once-off in every category. So we're going to go and manipulate this other particle system to also have a set of properties here that we can go manipulate. So first and foremost, let's go and rename it. I'll call this Embers. Again, so that we can identify it down the road. Now you'll notice as soon as you make any changes, the particle system resets. Okay, so if I put Embers to 1 and back to Embers, every time I hit enter, when I commit a change, it is going to restart the emitter so you can see the entire thing from the beginning again. That's the only change I need to make here. In required, we're going to go and make a few changes as well. First, the facing ratio, or how these planes are going to be aligned, I'm going to align them with their velocity. This is going to make it so that when they move, that's how the plane is going to be oriented. So we can put a little bit of motion blur on these suckers, and they'll actually stretch out in the right direction. So we're going to align them with their velocity. We don't need to change their sort value because we're going to blow them all over the place, and we won't need to do that. Let's give them one loop so that they also live within the same particle system. Let's shorten the amount of time that they can be generated. So again, when I think of this logically, there's going to be an initial burst of energy when this thing explodes, and then it kind of turns into smoke and vapor. And I don't want embers to be generated from the smoke and the vapor. So by setting our emitter duration to a much shorter time, say 0.35, the emitters die out while the smoke is still there kind of drifting, which makes a little bit more sense to me. The other thing I'm going to do is I'm going to go into the delay, and I'm going to give this maybe a 0.15 delay so that they don't spawn right away. They kind of come in a little bit afterwards. Again, we're growing out this particle, the first particle system or the first emitter. And so we don't want these ones to appear before the boom is there. So giving them a little bit of a delay is going to make sure that they kind of appear after the big smoke does. Now, you might have noticed that there's an empty spot here between our emitter properties and the modules. That empty spot actually gets filled with a special module. Our first emitter did not require any kind of special module, and as such, it's empty. But this module is, or this emitter is going to require some special properties. We want to have a lot of sparks. And sparks can be pretty expensive, especially if they live on the CPU. And so we're going to shift around the way that these particles are created to make them a little bit cheaper to have a bunch of them. This is in the module called type data. This determines the overall class of emitter and how it's going to exude particles. In here, you'll find things like trail data. This is what you get when you have a trail of particles following a bone. Beam data. This is useful for creating a large beam of particles, a large strip. Jedi Fallen Order uses this for their lightsabers. Mesh data. Mesh data will spew out polygonal meshes. So if you had a chunk of a barrel, a little tiny piece, you could turn this into a mesh data, and you could spew out pieces of your barrel. This is the kind of thing you see when you see instagibs. Right? You shoot a character and they kind of explode and you get little bits of gore everywhere. Well, those are just little generic meshes that they spew out from a particle system. We have ribbon data, which is going to create a ribbon. And it's going to give you two bones and it'll create a ribbon in between them. Used for creating really nice trails. And then the one that we're going to use, which is type data, GPU sprites. So we're going to shift our sprites from being CPU based or CPU bound onto the GPU. Now, as soon as you make that switch, you'll see that it says GPU sprites in that empty spot, indicating that's what this kind of emitter is. Also, in our preview window, we're now getting a warning that the system has no bounds. In order to use GPU sprites, we need to tell the system just how big the external bounds of this system are going to be. This is actually a really easy thing to do. There's a bounds menu up in the top. Again, right next to where the background color was that we adjusted, there's origin access and then bounds. And if we go into the drop down here, there's only one thing that we can click, which is set fixed bounds. And when you turn that on, the system will update and the warning will go away. Okay, so you don't have to be in a module for that. You just need to go to bounds, use the drop down, and set fixed bounds. and the little warning will go away. Now, the system will actually work without the warning, but it's still better to get rid of it. Let's go into our spawn module. Let's go manipulate the way that these things are spawning. Just like before, I'm going to remove the spawn per second, or the spawn rate, set it to 0. We've lost all our particles. And I'm going to add a burst list, which is going to give me the ability to type in how many particles I want to create. Here, we can actually go a little crazy with these things. I can make 350 of them. And they're not looking so good just yet. We'll come back to the spawn once we have them looking a little bit more the way we want. It's hard to determine just how many is enough when they aren't doing what we want them to do and they don't look the way we want them to look. So we'll come back to our spawn. Next is our lifetime. I'm going to give them a maximum life of, I don't know, 3 seconds. This is going to make them live a lot longer than the explosion. That's okay. I kind of want them to live longer than the explosion. It's also not going to be all of them that live that long. Again, the explosion's going to die out, and then they start petering out. Let's go do something with their size. They too are defaulting to 25 units, which is really big for an ember. So I'm going to drop this down to 1.5, 3, and Z I don't need. And let's do a minimum of 1 and 2.5. Now when I do this, they're going to become little tiny itty bitty points of light here. It's going to make them a little bit harder to see. Because they're a little bit harder to see, why don't we go and play around with their color? This is going to allow us to see them a little bit easier. So again, I want these things to glow. I want these things to be glowing hot embers coming from this explosion. Right now they just look like little white ticks, which isn't good. So I'm going to skip over velocity for now, and I'm going to go to color over life. In the color for life, we don't actually need to change their color over time, though you absolutely could. You could have them born glowing hot and have them fade out to black as they cool. I'm going to make mine remain the same. So they're going to be a constant. Now I need it to be a, I'm in alpha over life. Let's put that to 1. I'm going to go into color over life, and I'm going to set them to be a vector constant so that they're only ever one color. This is a normalized value. Right now they're black, and so we don't actually see them. I'm going to reset this guy too. Oh, we got a crash. Let me go and open that back up. We'll see how far it's saved. So I will go in restore and go back into my VFX and go back into my particle system. That's the material. So it looks like I absolutely completely lost the particle system, which is kind of a shame, but not the end of the world. I'm going to copy this from another package. To get back what had been lost. And close this guy. So I'm just going to open up the location of my project here and copy this over from the one that I'm working from. And this will get us back to where we were. Okay. So there is now somewhat back to where I was. And we're just going to go and delete. The emitter that I don't want. And get this guy back to where he was. I'm just going to go and assign my materials correctly here again. VFX, explosion, and we're missing our other material, which I can go and generate. So again, VFX underscore embers, and I will in here particle color. And a radial gradient. And again, we'll just do a multiply twice. One, which is going to be color. One, which is going to be transparency. That's opacity. An emissive color. And then we'll go and set this to be translucent, unlit, and for use with sprites. And I've got my material back. Okay. So now I can go to my other emitter, required VFX, and we'll pull in the embers material. I'm going to go and delete the modules we had not yet created. There we go. So here's now the initial color, which has got them as this little hot glowing value. So the initial color that I've got here, while these are normalized values, 1, 1, and 1, which is 255, 255, 255, to give me white, Unreal allows you to blow these values past what their default maximum is. So in this case, I've got red set to 100 and green set to 25. So that's going to give me a pretty hot looking orange that's going to generate a glow. So let me show you this in the material, because it'll make a little bit more sense here. So let me render this on a plane. Let me turn off the grid again. So here's a vector 3 that I'm going to put into the emissive color for this thing, which should give us just a little black circle because there's no value in here. So if I wanted this to be a white object, right, we would go into this color, send it to white, like so, and that would be white. If I wanted it to be orange, we could go and zero out the blue and set the green value down a little bit, and we start getting some orange. But this doesn't actually glow. It isn't really brilliant. So if I wanted this to glow, we could take these values and multiply them by 10. So 1 times 10 is 10. 0.25 times 10 is going to be 2.5. 0 times 10, well, 0. And now this is going to start to glow a little bit. It's still the same color, but it's now starting to glow. If we multiplied it by 100 instead, come on, 5, we're going to get a glowing orange. And you can actually see brilliance coming off the side of this thing now. And this is how they do, again, in Jedi Fallen Order, it's how they do the lightsabers. If you wanted to have a glowing, evil lightsaber, we would turn off the value and just have the red color glowing. And in fact, if I were to go and give this even another value, we would get even more glow coming off that thing. So the values can be blown out and giving you something well beyond the range of 0 to 1. And that's what we're doing here in our color. The initial color, I'm using a default constant, and I'm just blowing these values out. So 100, 25, and 1. That's going to give me this really nice, hot, kind of orange color on this particle. The next thing we're going to do is give this thing some velocity. So let's go and make it burst. Let's go into velocity and give it an initial velocity. That's going to give us the ability to make this thing move. Now we really want this sucker to cook. We want this thing to really, really fly. So let's go into the initial velocity. And let's say, I don't know, 650, 650, and 650. So you can see we're kind of getting this shotgun effect now. And they're all going only in a positive direction, which is no good. So let's also add negative 650, negative 650. And I'm going to leave 0 here. I don't actually need to burst them down because that's where the ground's going to be. And so now we've got these embers kind of shooting out into space. Again, they're different every time, and so it's going to give us something a little bit more unique every time we see it. Sometimes we're going to get one come right at the camera, and sometimes we're going to get one go nowhere near the camera. Now, I want to fake a couple of things here with this to make it look a little bit better. I would like to, I'm going to go in here. I'm going to go to size, and let's do a size by speed. This is going to scale our particles so that their scale is pushed by the rate at which they are moving. Okay, and what this is going to do is it's going to give us the ability to stretch them out. So for instance, if I scale X out 1 and Y, let's scale 5 times and 3. You can see that they actually start really becoming oblong. It's a neat way of being able to change the shape of what is essentially just a little tiny circle to push them out a little bit more. And again, this is being determined by the speed of the particle. So the faster the particle goes, the more that stretch is going to happen. This is kind of like a multiplier. Now, I don't want them to conserve all of that energy. I don't want them to constantly have that energy. There should be something in the world slowing them down, which would be the atmosphere. I'm going to fake the atmosphere in here. We're going to make these things kind of slow down like they were pushing up against the air around the object. To do that, I'm going to go to the area called acceleration. Acceleration determines the speed that these things have over time. So we are going to add a drag. You'll notice with drag on, they burst out, but they kind of start slowing down. I'm going to set drag to 1.5. This is going to give them the effect of essentially looking like they're pushing up against the atmosphere and the atmosphere is slowing them down. Which is cool, but I don't like that they freeze in space. That's not the way that the world works. So let's fake some gravity too. Gravity is another acceleration. This one is a constant acceleration. And we can go just type in how fast we want gravity to behave on these things. Gravity is going to be down, so negative z. And we can do 980, which is essentially gravity. They're going to pull down at 9.8 meters a second. Now the original blast still pushes them out. You can see that we're not getting as much height out of them anymore. before they start dropping down. So maybe we go into the initial velocity and let's add a little more velocity. So at least they burst out again in every direction before falling. So yeah, just a constant acceleration of negative 980 in Z will give them the essential acceleration that gravity would give them. Let's do one more thing to make them a little bit unique. So let me just show you what this thing looks like in the world now. I'm going to just drag it into the world. I lost it. There it is. So you'll notice when this thing spawns, and I'm going to pull this guy off here so we can see it. I don't need that open anymore. I'm just going to restart it in the level a couple of times here so you can see this. Our particles keep going well below the ground. That's no good. That's not what we want to have happen. So we're going to fake a little bit of other stuff here. I'm going to add another node. And this one is going to be a collision node. So collision. What this is going to do is it's going to use the scene depth, essentially how far things are from the camera, to tell the particles to collide with those things. Now we have three options for what happens when a particle collides. We can, that's the scene depth, where are you? Here we are. We can make the particles bounce. We can make the particles stop, or we can destroy the particles. So depending on what kind of effect you're doing, you know, sparks that generate over water would probably kill when they hit the water. Sparks like ours are going to bounce when they hit the ground, and there may be some kind of effect you want to have stop when it hits the ground. So we're going to just turn that on, and if I go and reboot the system here in the world, you'll see our sparks now kind of collide with the ground, giving us a pretty neat looking effect. Makes it look a little bit more dynamic. Now, in my opinion, I think they're lasting too long. I think we're getting, I mean, the little sparks are cool, but they seem to just, they stick around too long. So let's go into our lifetime and shrink this down a little bit. Let's do 2 seconds. That's a little better. I dig it. I think that's looking pretty good. With that, I'm going to call this emitter done. And we've got but one more emitter to go and add. Now, earlier I spoke about the two buttons on the top of our emitter. The check mark, which turns it off and on, and the solo button, which eliminates everything else but the emitter that you're selecting. And I didn't speak about what the third button does, the one in the middle, I guess technically the second button. Currently, it looks like a bunch of little dots, which is particles. If you click on it, it'll switch from particles to what's called dots. We're going to solo this guy out. This is points, meaning it's just showing us the XYZ position of those dots. Actually, because we're changing this guy, let's do this with a new emitter. Let's make a new emitter. Let's turn this guy off as well. So here's the new emitter. There are particles, dots, points. These are locators. So dots are XYZ positions in space. These are XYZ positions in space with a little line on it to show you where it is. And the last one is a light bulb. This gives us the ability to spawn a light on our object. And that's going to help really tie this into the world. So when this big, large explosion happens full of energy, we're actually going to see a light spawn as well, lighting up things near it. That's going to give us a really cool effect. I'm going to go make sure that we name this. I'm going to go and make sure I'm looking at this thing. Now, this one's a little bit tough to edit because we're not going to see anything in the world here because nothing is being lit. And so it does make it a little bit more difficult. I'm going to go to required. And I don't care about the actual texture of this here. We can go and remove that. We are going to change a couple of settings here that we haven't used before. So first, we're going to use local space. And that is going to make the light generate in relation to where the emitter is. This allows you to do things like move the emitter quickly and have the light go with it. Kill on deactivate. That's going to turn off the light once the emitter has been deactivated or the particle system has been deactivated. If you don't turn this on, every time an explosion happens, you're going to add a new light to your world, and eventually you'll have too much light. Also, we're going to kill on completion. So when the particle system finishes and we get that little completed written in the bottom, that again will deactivate our light. Now you notice it doesn't say completed on here anymore, and that's because, again, we're not looping indefinitely. I got to go put a 1 in our looping mode. Also, I'm going to turn down how long this light is turned on. Its duration, 0.25 of a second, quarter of a second. I just want a flash of light, and that's all I really need. Now you can play around with this to get it to line up a little bit more with your particle system so that they are very much in sync, so that when you see the hottest part of the textures on screen is when that light is on. Lifetime is next, and I'm going to give this a constant. Let's give it 0.35. So the light's only on for a short amount of time. We can go play with its size. I'm going to give it a maximum of 50 and a minimum of 40, and I don't care about the other numbers. That's going to make sure that the light is coming from a large enough source. I'm going to adjust its velocity by deleting that module. I'm going to adjust its color. We're just going to do a constant again, not in alpha. Let's undo that. Okay. Color over life that I want to be a vector constant. And let's go give this the same color we put in our particles. So 10, 2.5, and 1. Give us a nice bright orangish light, something similar to the color of the ember and the flames. I also want to give this an initial location. I'm going to right-click and go to location. This is going to give us the ability to place the light within our scene here. So location and initial location. And the only thing I really want to do here is just move it towards the user in X. So if you look at our little coordinate system here, we're kind of looking at this thing from positive X. And so I'm going to go into X and I'm going to give this a value, and I'm going to set this to be a constant vector. And let's give this a value of something like 20. So this just moves the light towards us in the system a little bit. That's going to make sure that we aren't going to be hiding the light behind our particles. Finally, we need one last node or module in here, which is just going to help us control the light bulb itself. That is called a light. And when I create this, inside here, we'll get some properties for the light. Fall off, color scale, radius. I think everything else should be good here for now. And so I'm just going to go and save this guy. I'm going to come back and edit these settings. Again, we need to see it in action in the world before we know just how well it's working. I'm going to close the particle system. And let's go see how to now add this to our world. I'm going to open the level blueprint. And I'm going to go look for the area where we are destroying our barrel, which is right here. Barrel, destroy actor. Well, if that's where the actor is being destroyed, that's where we need the particle system. So, in the area in front of it, I'm going to right click, and we are going to spawn an emitter at location. This is going to spawn a particle system wherever we tell it to. We're going to make sure that this happens before we destroy the barrel. That way we can kind of mask the fact that the barrel is disappearing a little bit. A little smoke and mirrors. Then we're going to go and choose which emitter. This one. And now we have to tell it where to spawn the emitter. Well, we know where. Spawn it wherever the barrel is. So, if I get the barrel's location, get location, get world location, I can just plug that into the location. Now, I'm not going to care here about the rotation or the scale. I can just leave them exactly where they are. I'm going to move this above here because those things are all tied together. This system is complete. This will auto-destroy when it's done, and it'll auto-activate starting it when it needs to. So these 4 nodes are all that's required to get this particle system in our chain to work correctly. If I compile and hit play, well, that's no good. I left one in the world. So let's hit play. Here comes the barrel. I'll hit my explode button. And we get an explosion. I'll reset. We should get another barrel. Unless it falls off my treadmill. It fell off my treadmill. I've got a little too much rotation going on. My barrels keep falling off. There we go. And so yeah, it doesn't matter where the barrel is in the world, it appears that the explosion is exactly where it's supposed to be. And it ties in really well with the camera shake, giving me something really, really nice. That's it. That is the whole kit and caboodle. The whole process for getting a visual effect kind of built and then assigned to the location in the world.